All right. Hello, everyone. Welcome to the International Methods Colloquium. I'm Justin Nessery, an Associate Professor of Politics and International Affairs at Wake Forest University. The International Methods Colloquium is a periodic online interactive seminar discussion on the application of quantitative methods to social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. The IMC is affiliated with the Society for Political Methodology, who hopes that you will support quantitative research in political science by joining. The membership fee is just $10 a year for graduate students. I will post a link to join the society in the Zoom webinar chat window after this introduction. This week's speaker is Moritz Marbach, a postdoctoral fellow at ETH Zurich, giving a talk entitled Profiling Compliers and Non-compliers in Instrumental Variables Analysis, and this is joint work with Dominic Hongartner. Moritz's talk will last between 30 and 40 minutes, after which point we will take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window, and you can ask a question at any time, but we will hold questions till the end of the talk unless they're definitely clarifying questions and very short. A link to the paper and slideshow for this presentation will be available in the Zoom webinar chat window, and I will post those links right after this introduction is finished. And now I'd like to welcome Moritz Marbach to the IMC. Welcome.
Thank you, Justin. I'm very excited to be here. Thank you for the invitation. So as Justin already pointed out, this is a joint work with Dominic Hongartner. And as many of you know, instrumental variable estimation is an important part of our toolkit and for empirical researchers to address, on the one hand, non-compliance and experimental studies, as well as unobserved confounding in observational studies. And so while IV estimation has been around for many years, in fact, the first paper has been written in 1928, it probably took until Don Rubin, Guido Immens, and Joshua Angres published their JASA paper in 1996 until we really understood what instrumental variables are doing and what type of treatment effects they're capable of identifying. What they show in their paper using the potential outcome framework is that unless you make the very strong assumption that all treatment effects are homogeneous across all units, instrumental variable estimation is really only able to identify a local average treatment effect. And local here means in a sense of that they identify the average treatment effect for the complier subpopulation. So only a subset of the units in the population. Compliers are in some sense peculiar in that when they are encouraged by the instrument to take the treatment, these units do take the treatment. And if they are not encouraged by the instruments, they don't take the treatment. So they do what the instrument tells them to do. So a natural question then is, and a practical question in applications of instrumental variable estimation is, to what extent are compliers different to non-compliers? So in particular, in situations where there are few compliers, so where there is a small complier share, so a small first stage in an instrumental variable estimation, we wonder to what extent compliers might be observable different to non-compliers, which is important when we want to think about the generalizability of delay, because we might worry that when this is only a local average treatment effect, which is identified by a particular instrument, how generalizable is that treatment effect if we would use a slightly stronger or slightly weaker instrument, or even had the ability to force units to comply with the treatment. And so when we reread a little bit the literature, in fact, we read all articles in the last 6 years published in, on the one hand, political science journals, the top journals in political science, as well as the top journals in econ. There are quite a few papers published every year that use instrumental variable estimation. You can see here in this graph, so when you look at the reddish bars, most of these papers are in econ journals, but there are quite a few also every year in political science journals. And so when we then look actually to what extent they do profiling in a broad sense here, so to what extent they study how compliers differ from non-compliers and observable attributes, there are actually only a very few pieces, 10, and all of them in this time frame here, 2013 to 2018, all of them are actually in econ. We found only a single paper in political science, a paper by Joel Pianzola and a couple of colleagues that does profiling. So that studies the characteristics of the compliers relative to the non-compliers. And that is in some sense surprising because we are hardly the first ones to point out that profiling is possible and might be actually useful. So when you look at Angrist and Pischke's textbook, mostly harmless econometrics, they suggest to look at the likelihood that compliers have a particular characteristic relative to the entire sample. That is, in some sense, a little bit limited in that it only works for binary covariates. So you can't quite directly apply that to continuous covariates. But there are others. Here, a paper by Yochi, Chang, and Small, published in Statistics in Medicine, that suggests to weight the sample, which essentially boils down to a form of kappa weighting, which is known from Abadi's paper in 2013 to construct log estimates. And actually that weighting formula is also being pointed out by Angrist and Pischke in a footnote in their book. Again, they only look at, or they like this approach only enables you to study the complier mean, so look at the compliers, but you can't quite compare it to the always and the never takers, or they don't do that. And then the third approach is in Paolo Pinotti's piece in 2017. He regresses an interaction of the covariate and the treatment indicator on the instrumented treatment in a two-stage least squares. And this surprisingly actually identifies the complier mean, but it turns out to be statistically a little inefficient since it only uses a proportion of the sample to estimate the complier mean. So this paper is really not saying that we are the first ones to ever do profiling, and we can only speculate why this has not been why these approaches have not been applied much more widely. But we believe that our approach, which we hope is quite intuitive, and we provide easy to use software to implement it, that this approach finds wide applicability and becomes standard practice to do these types of profiling, to talk about and have an informed discussion about the generalizability of the late. So how do we actually do this profiling, and how do we can estimate the complier mean? So how can we do the profiling? So in order to explain that, I need to do a little bit of notation and set up here. We generally follow the notation and sort of the usual approach of setting up instrumental variable estimation in a potential outcome framework. So we have a binary instrument called Z here, takes a value of 1 if a unit is encouraged to receive the treatment, and a value of 0 when that unit is not encouraged to receive the treatment, so to receive the control condition. Then there is an observed treatment indicator D, which is realized as a function of potential treatment indicators, so the potential treatment. And this is, again, a function of the instrument. So to the extent that the instrument here takes the value of 1, then the potential treatment under the instrument value 1 is realized for the treatment indicator, the treatment intake. And then, as I already pointed out, there are different types of compliers that we can define. So there are 4 compliance types, or principal strata, more generally speaking. The compliers are units that take the treatment if they are encouraged. The defiers are doing the opposite. So when they are encouraged to take the treatment, they don't take the treatment, and if they're not encouraged, they take the treatment. Then they are always takers, so they always take the treatment, and the never takers, they never take the treatment. We can define them based on the potential treatment indicators here. So if the instrument takes the value of 0 for the complier units, the realized treatment value here is 0, while when the instrument takes the value 1, the realized treatment takes the value 1. So again, compliers do what the instrument tells them to do. They realize a treatment value of 0 if the instrument is 0, and if the instrument is 1, they realize a treatment value of 1. The defiers are doing the opposite. So again, if the instrument here takes the value of 0, they realize a 1. If the instrument realizes is 1, they realize a 0 here. For the always takers, they always take the treatment. So that means independent of what the instrument is, they always realize a value of 1 for the treatment intake. So they always take the treatment. And the never takers, they never take the treatment. So you always have a 0 here. Now, in order to get the intuition for our approach, it's useful to consider this. I'm jumping a little too fast here. So before I tell you about the intuition, I have to actually tell you what we want to estimate. So the estimates here are the means, in particular the means for some X covariate for the compliers. So this is a conditional mean for the compliers here, as we just defined. So for all the units that are compliers, we want to know the mean for some X covariate. And then similarly, we want to estimate the mean for the always takers and for the never takers. And then just to complete the set here, we also have the overall mean across the entire sample. Now, you already see here that the mean for the defiers is missing, and this is because, this is what we now actually have to talk about, that there's an identifying assumption, namely the monotonicity assumption. So the monotonicity assumption, which we invoke here as well, so this is quite familiar from instrumental variable estimation. The monotonicity assumption says that there are no defiers. So we will not be able to estimate the mean for the defiers because the defiers don't exist by assumption. And then there is the independence of the instrument assumption, which is on the one hand the independence of the instrument with respect to the potential treatment indicators here, as well as with respect to the X, so to the attribute that we are interested in profiling. So essentially what this assumption implies is that the observed never takers and the observed always takers are identical. This will be trivially fulfilled when you have like an instrument that's randomly assigned. So in an experimental context where you encourage units to take the treatment or not take the treatment, this assumption will necessarily hold. And now notice here that the exclusion restriction is not necessary. This is just because of the fact there are no outcomes we don't need to consider outcomes here. And the exclusion restriction, of course, speaks to the outcomes and not to the relationship between the instruments, some X attribute and the treatment indicators, the potential treatment indicators. Okay, now so coming here to the intuition, so we consider this 2x2 table where we have in the columns the instrument and in the rows the realized treatment. And each cell now is populated by 2 types of units. So in this cell, when we consider this cell here, those units could be either compliers or they could be never takers. Since we don't know to which of these latent strata these units belong to, we cannot directly observe if a unit is a complier or never taker, but potentially it could be a complier. So when not encouraged to take the treatment, unit doesn't take the treatment, so it's consistent with the complier definition. But a unit could also be a never taker. So when not encouraged, independent of of what the instrument's value here is, never takers never take the treatment. So a unit in this cell, in this broad cell here, could also be a never taker. So we cannot discern whether or not a unit in the cell belongs to complier subpopulation or to never taker subpopulation. And the same goes for all of these other cells as well. However, now when we invoke the assumptions that are lined up on the previous slide, then we know that we can actually drop the defiers. So the defiers don't exist. So we know that the units in this cell and in this cell are solely made out of never takers and always takers. Now, importantly, what I've already popped up here is the formula, and it's just a simple accounting formula, if you will. The overall mean as a function of the subpopulation means, so the mu's here, as well, and those are weighted by the share, so the proportion of this subpopulation in the data. Now, if you drop the defiers, this formula simplifies a little bit already, and that we only then have these three subpopulations in here. And you might already now guess what happens. Well, when we think about the independence of the instrument assumption, then we know that the never takers in this cell and the never takers in this cell are equivalent in distribution. The same goes for the always takers and the always takers here. So what that means is that we can simply use the never takers in this cell to estimate the mean for the never takers, so to profile or to profile the never takers using observations in this cell. So we can easily estimate the mean here using simply taking the values for the x here for all the units in this cell. And we can do the same with the always takers here, so we can estimate their mean using the observations in this cell. And what we also can do is to actually estimate the overall mean across the entire sample. Now, when you then look at this formula, then you already notice that, well, we have already all these quantities here highlighted in blue, and the only thing that's actually left are these two quantities here to the right. So this is the complier mean and the complier share, right? Now, when you think about instrumental variable estimation, you know that you can easily estimate the complier share. So when we then rearrange the formula, and to solve for mu here, we end up with a formula that's only a function of observable quantities, recognizing that this complier share here can be estimated based on the entries in these two cells. This is just the complier share. This is just the first stage from any instrumental variable regression, right? So with that, we have on the one hand the complier mean, as well as the never taker mean and the always taker mean identified from these two cells. Now, when we then want to actually estimate this, we take these population quantities and we simply plug in the sample analogs to obtain our estimates. So we use the sample analogs to get our estimator. And then for the standard errors, we suggest to use bootstrap standard errors and as well as to construct the confidence intervals. And in the paper, we do a bunch of Monte Carlo simulations to validate the coverage rate and the consistency. Now, let me show you a couple, two examples actually. So the first example here comes from a paper by Albertson and Lawrence in 2009 on the proposition 209, proposition 209 experiment. This paper is really motivated that papers in political science that do something with instrumental variables always go back to this data and demonstrate how to apply a particular method. And so we thought we also use that paper to demonstrate how to do profiling using our approach. So the context of this example is as the 209 initiative in the California ballot proposition 209, which was on abolishing affirmative action. It actually passed, so it actually abolished affirmative action. And so Albertson and Lawrence, and they ran this experiment in Orange County with about 500 participants. And some of these participants, those that are encouraged to take the treatment here, they are encouraged to watch the Fox News debate on affirmative action on the evening before actually voting on the Proposition 209. So they had a baseline survey where they collected a bunch of characteristics about these responses, and some of them got encouraged to watch this Fox News debate. The encouragement here takes the form of a reminder that these participants received about this debate, a refrigerator magnet, and $2 that they've been sent to. The treatment then is to what extent they actually watched the Fox News debate. So they had a second follow-up survey after they voted on this proposition. And so when you look at the crosstab here, what you see is that there's quite a bit of non-compliance. So this is the instrument and this is the treatment. If there would be full compliance, we would only observe values on the diagonal, and all the off-diagonal elements would be 0. But as you can see, they are not. So there are at least 142 never takers here, and at least 11 always takers. Now, keep in mind that some of the never takers are also here, and some of the always takers are also here. That's why you can only say that there are 142 never takers, at least, or observable never takers, so to speak, and observable always takers. Now, what they find in their paper is that there is no effect on vote choice. So for the compliers, so those that have complied with the treatment assignment here, there's no discernible effect on their vote choice, but they do find that there is an increase in self-assessed knowledge, actually. Now, let's do some profiling here. So this is simply if you will, this is the first stage. So this is just the complier share, and this is the share of never takers in the data, and in the share of always takers. So you see the always takers is a very small share here, which is why the confidence intervals then later for when we look at these attributes are actually always quite wide. Now here are a couple of demographic characteristics. Those come from the baseline survey. So as you can see, based on our estimates, never takers tend to be more likely to be female. There's not much in terms of to what extent they're white or some other race. Education, not much of a difference. Income, and a little bit in terms of ideology. So compliers tend to be a little bit more liberal. But the real differences are when we look at a political interest, TV news consumption, and newspaper consumption. So here what we see is that compliers are much more likely to be political interested relative to never takers and the always takers. They are also much more likely to watch TV news, at least relative to the never takers, although not much in comparison to the always takers. And they are more likely to read the newspaper compared to never takers and the always takers. So now that's an important finding, because when we now think about, and we call this an informed speculation here, when we think and have some do a little thought experiment, if you will, and think about a slightly stronger instrument. So say we had given them $3 instead of only 2. Then some of the marginal never takers here might be encouraged to take the treatment, so they become compliers, right? And so probably these marginal never takers would be politically less interested. And so we might think that the effect that we estimate for the compliers when it comes to self-assessed knowledge might be actually a bit larger, since these marginal never takers that then become compliers with a stronger instrument are a little bit less political interested, and so there's more that they can learn from maybe from a Fox News debate. So here we would probably conclude, given these differences, that there's little reason to assume that delay generalizes to all participants if we would use, or in general, to all participants if we could force people to watch this debate, but also probably doesn't generalize if we use a slightly stronger or even slightly weaker instrument. Now, again, we cannot, of course, not identify what the actual late would be, unless we rerun the experiment with a stronger instrument. But the point here is that we can like think about or form conjectures about how the late could be different when we have a slightly stronger instrument by looking at these profiling results. Now, let me show you a second example here. Media experiment by Gerber, Carlin, and Bergen, and published in 2009 as well. They run an experiment in the Prince William County. In case you don't know where that county is, here's a little map. This is Washington, D.C. This is the Prince William County. This experiment took place in the context of the Virginia gubernatorial gubernatorial elections in 2005. So they had a baseline survey where they identified non-newspaper readers, and then they sent some of them a free subscription, or they given them a free subscription to the Washington Post, and then actually also to the Washington Post. But for the purpose of this exercise here, we focus simply on those participants that received this Washington Post encouragement. So they got this free subscription to the Washington Post, and the control group. So the control group here are people that don't read either the Washington Post or the Washington Times, so they don't read a newspaper essentially. Again, we have about like 500 participants here in this experiment. And the instrument here, the encouragement, is the free subscription to the Washington Post that these respondents received. And the treatment is to what extent these respondents then later on in the follow-up survey after the election actually report to having received the Washington Post. Again, a similar picture to what we had before. So this is the instrument, this is the treatment. So what we see is that there is a bit of non-compliance. Again, when there would be full compliance, we would only have values on the diagonal, but we actually do see quite a bit on the off diagonal. So there are at least about 90 never takers and 36, 63 always takers. So in the paper, what they find is that there is not much of an effect on political knowledge, policy positions, and turnout, but they do actually see an increase in Democratic candidate support, which is consistent with sort of the idea that the Washington Post tends to be more left-leaning and support Democratic candidates. So when we look at the profiling results, we see that here we have a little bit more sort of, so fewer compliers, fewer never takers, and then a little bit more for the always takers. So it's about like 35% compliers, almost 50% never takers, and then fewer than 25% always takers. There are quite some differences when it comes to age, and for when we compare the always takers to the compliers, and to some degree the never takers. A little bit of differences for gender. Not much in terms of self-reported turnout in the previous elections. And we see that the Republican candidate here, so the never takers, tend to be a little bit more in favor for the Republican candidate. So keep in mind, so this is a Republican candidate in these gubernatorial elections, and this has been asked prior to receiving this free conscription. So all these covariates are pre-treatment. So the assumption here of an independence between the instrument and these covariates is quite plausible. Now, again, like some informed speculation. So think about a stronger instrument where we, in addition to the subscriptions here, actually add a cash benefit to that maybe. So we give these respondents that receive this free subscription also some monetary some cash so that they read the newspaper. So again, this might encourage some marginal never takers to actually read this newspaper, and so to the extent, since they are like more Republican leaning, we might think that the late is actually a little smaller. So again, here we would probably not think that the delay generalizes to all participants or to participants that are encouraged to become compliers by using a slightly stronger instrument here. All right, so if you're now excited about this and would like to use it in your own research, we have software for you. We have a Stata edu file as well as an R package. So you can download both from the GitHub repository. I'll have the link on the last slide. It's fairly easy to use, in particular in Stata, but even in R. So you just simply type ivdesk and then the attribute, the treatment and the instrument. And for R, it's essentially the same thing. And you get like the mean, the bootstrap standard errors, the proportions, and the bootstrap standard errors for these proportions. We also have implemented a balance test, so you can directly test the balance with respect to the X covariate. And we working on some extensions that I want to briefly talk about now. So the one question that we always get, what about an observational IV? And when you have like not experimental data, but observational data. So in general, we recommend then to do at least some balance testing so that you see to what extent there is balance between those that have been encouraged and those that have been not encouraged, which is then with observational data not guaranteed by design. And the package does that automatically for you, actually. It gives you a p-value for the difference between these two groups. Speaking of two groups here, what about a continuous IV, continuous treatment situation? So this is a little tricky, so to speak, to generalize the method to these types of situations. For now in the paper, we discuss or we suggest the option to dichotomize, keeping in mind, of course, that different types of dichotomizations lead to different types of compliers and never takers, the different shares of compliers and different shares of never takers and always takers. Which means that the profiling, the results that you receive, of course, depend on the dichotomization. But one plausible strategy might be to, in particular, when you have a continuous IV, to dichotomize such that the first stage is largest, such that the complier share is largest. But yeah, that's certainly a limitation of all the methods that I've already mentioned earlier, as well as our method. That it's not quite so clear how to generalize this to the continuous treatment continuous instrument case. And last, we, with the help of some colleagues here at ETH and the statistics department, they figured out the analytical standard errors for the complier mean, which is a little tedious to get at. And we hope to have this implemented in the package soon, so that you don't have to rely on the bootstrap standard errors. That being said, since the computation is quite quick, typically for moderately sized data, you probably don't even feel much of a difference because it runs relatively fast, even with the bootstrap. But we nevertheless hope to have the analytical standard errors included in the package very soon. And now, as promised, this is the link to the GitHub repository where you find the edu files as well as the R package, or you can directly install the package from Crane. And we also have a working paper on SSRN that you're welcome to download. And I'm now looking forward to your questions.
All right. Thank you, Moritz, for that presentation. At this point, Moritz Marbach is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And while we're waiting for some questions from the audience to come in, I'd like to ask a few questions. So you noted at the very end there that in observational data, when you're using an instrument, you recommend balance testing. For covariate balance, I assume, across values of the encouragement. But I think that it is possible to argue that the instrument only needs to be independent of the outcome conditional on those covariates. So in other words, if, for example, I have some sort of instrument and I think that it affects the treatment, it doesn't affect the outcome except through the treatment, conditioning on some set of X's, then the instrument is valid. In other words, conditionally valid. And I guess I'm wondering, in that sense, or in that case, would it still be a good idea to do a balance test? And if so, how do we account for the fact that the instrument is only conditionally valid?
Yeah. So let me clarify this a little bit. So the axes here, that the axes that I talked about, are sort of the covariates that where we want to do profiling on, right? Mm-hmm. If we believe that these axes are necessary to render the independence of the instrument assumption plausible, then we can't do any profiling on these axes. So we can only profile once we have independence of the instrument. So if the instrument is independent from these axes. So what that means is that essentially what we another extension that we would like to have is to have the ability that you can first condition on some axis and then do profile with respect to some other axis. So say you have like a covariate matrix Z here, where that you want to condition on, and that you believe that conditional on these Z, not Z, so W. Let's say like you have a set of W, right. And you believe that the instrument is only independent with respect conditional on W. Then we would like to have an extension where we can condition on and then do the profiling with respect to X. This would be easy. I mean, so what you could always do is stratification, right? So you can stratify with respect to W, and then do the profiling within each of these strata, and then combine the results back to an overall profiling result. That's possible, but it's also, of course, like might be quite inefficient if you have like a small when you have a lot of strata and only little data. So what I think what we will have in the near future for the package is sort of like this stratification option, but like how to do this like in a more say like if you are comfortable assuming some sort of linear relationship and want to like to condition on W in a linear way, how to do this is a little bit less clear. But for now, like one way to do it is to do the stratification.
I also wanted to ask you, you mentioned something about dichotomizing a treatment versus looking at the continuous version of that treatment. And am I correct in, before I ask this question, I want to ask, am I correct in saying that you're recommending, or at least suggesting, that it might be feasible to dichotomize a continuous treatment so as to be able to profile?
Yeah, so I mean, so the only way, so to speak, so if you have a situation where you have a continuous treatment and or a continuous instrument, and you wish to do profiling, then for now the only option is to do some sort of dichotomization. That's of course not ideal. We would like to have a more general way to do this, but so far it's not really clear how to generalize this approach or any of the other approaches to this situation.
Well, in that case, I think it might be a good idea to check out a recent paper in political analysis by, I think, Marshall about coercing bias. Because, maybe if you only dichotomize the instrument strictly for the purposes of descriptive profiling, and then you actually execute the real model, the sort of the substantive model using the continuous version of the instrument, maybe it's fine, and maybe it doesn't matter. But I think if you were to use the dichotomized instrument, you might run into some problems. I remember, I read this paper quite a while ago, but I remember that it induces some form of bias. Just the act of dichotomization can cause problems. Unfortunately, I didn't read another paper while you were giving a presentation, so I'd have to go back and look exactly at what it is. Are you familiar with this paper and the concept of?
Yeah, I mean, so yeah, so I mean, it's in some sense even worse in that, like, I mean, the profiling that you do with dichotomization, right, doesn't necessarily have to correspond well what then actually, like the set of compliers that you use in order to in the instrumental variable estimation, right? So it is not ideal to do this decolonization. My view is, and that like you might do this nevertheless in order to get a sense of how different are compliers and non-compliers, to get a sense of like how much of a difference there is. Of course, understanding that this decolonization like might considerably that the profiling might considerably change once you dichotomous in a different way. I think the only recommendation really like would be to choose like a cut point that maximizes the complier share, so that like you have a lot of compliers, so that you might hope that a slightly stronger or like a slightly that when you choose like a cut point that's a little different, that it doesn't disturb the profiling results too much. But again, I completely acknowledge that this is less than perfect, and we need to do more work on how to generalize this to a continuous treatment, continuous instrument situation.
So my last question is more speculative. You spend a lot of time in the talk talking about whether a late will generalize to an overall population, given that you're only really estimating it on a subpopulation of compliers. And that got me thinking about potential mediation and really more like moderation effects, and the possibility that you might be able to recover those moderators if you had, let's say, 6 or 8 different encouragements with 6 or 8 different profiles of people who tended to be compliers and not compliers. Would it be possible technically to extract the degree to which complier characteristics are influencing the impact of the treatment? So what I'm really getting at is, would it be possible to develop a model of treatment effect strength conditional on mediate or really moderating covariates if you had more than one encouragement, and those encouragements all had different compliers?
Yeah, so I mean, not sure what would happen if they all have very different complier sets. But you could think of a situation that I tried to sketch, where you sort of slightly increase the cache that you hand over to respondents, right? And so that increases the strength of the instrument. So some of the marginal never takers become compliers. And so in that situation, when you have these multiple instruments, in a sense of that some like these instruments increase in their strength, right? You could probably construct the function and predict what would be the profiling look like for a hypothetical instrument that's even stronger. In terms of like to what extent it's possible to predict the late for that for the non-compliers, so for those units where you don't that are never part of a complier set, there is a paper by Peter Erner and colleagues that essentially, like, I think it's called Beyond Late, that essentially suggests that like we could do reweighting on observable characteristics to essentially generalize the late based on some other assumptions that we would have to make in order to do this type of reweighting. But of course, you like once you invoke certain assumptions, you could start generalizing the late. In fact, the easiest assumption to generalize the late is to assume treatment effect homogeneity, right? Like then you're essentially like generalized across the entire population. But that's a very strong assumption, and so like Peter Erner's paper is essentially about, okay, can we do something in between, which we can when when we make some assumptions about sort of conditional independence.
All right. Well, I'm out of questions, and I don't see any questions from the audience, so I'm going to close the talk. I'd like to thank Moritz for being our presenter this week, and I want to remind everyone that this presentation will be posted to our website shortly after the broadcast if you'd like to share it with someone else or watch it again later. I'd also like to announce that this is the last IMC talk before everyone goes on winter break. So enjoy your winter break, and when you come back in the spring, I hope you'll join us on Friday, February 7th, when we will 2020, when we will host a talk from or by Walter Mebane from the University of Michigan. You can check out our website www.methods-colloquium.com to get more information about this upcoming talk. Moritz, thanks a lot for being here today.
Thank you, Justin.
Have a good break and see you next year.
Bye-bye.